So if you have the time to write FOIL over top of it, that way it can help you see the patterns. Notice that every single time, once we simplify, the O and the I go together, right? But the first ones still stay ones were, and the last ones always stay what the last ones are. How many people are done writing it down? Okay. Wait a couple more seconds. All right, now that we got our notes covered, we're just going to take the answers here. Whoa, make them really big. Let's make them a little smaller. So there are the 6 answers with the FOIL. And what we're going to be doing now is factoring. So the question is, if we went backwards, this is going to equal what times what? And that's why I wanted you to cover your notes so you don't just read it off of there. I hope no one has a photographic memory that they've memorized all the numbers. Okay? Then we're going to look at this one and work backwards and figure out what was in here, what was in here, what was in here, and what was in this last one. Okay? And the reason I wanted you to look for a pattern and see that the first ones always are the x squared, the last ones always stay the same, and the outside and the inside get combined. Okay? Because that's going to help you figure out how to go backwards in one step to what we started with. Let's look at our first ones. If we know that our first ones give us x squared, can you see that this has to be x and x? This is where factoring is harder than foiling, because when I get to 14, I've got options now. It could be 1 and 14 for the last ones, or it could be 2 and 7. Can you see that? Now, we need the outside and the inside to combine, so I'm going to think this is my outside, this is my inside. So whatever numbers I put for my last ones, I also have to think that my outside and inside have to combine to get 9. So if I did choose poorly and choose 14 and 1, can you see now that my outside is 14 and my inside is 1? Does 14 and 1 ever add or subtract to give you 9? No. So we make that go away, and we try 7 and 2. Now my outside is 2, and my inside is 7 x's. Does that make 9 x's? Yes. And then we have to make sure we get our signs right, because they could be both positive or both negative to get a positive 14. But since we need a positive 9x, they'll have to both be positive. So we look at the first ones and the last ones to give us hints, but then we're going to have to tweak it sometimes to figure out what the last ones and where the numbers are going to be. Now for the second one, what's the only way you could get a 2x squared with your first ones? What has to be here and here? 2x and x. That's the only way, right? I mean, x and 2x is the same thing. So we start with 2x and x. Now we need to put something that makes 3 for the last ones. What makes 3? 3 and 1. Does 1 and 3 also make 3? Yeah. And for this one, it's going to make a difference, because if we think about our outside ones, here's our outside ones, and here's our inside ones. If I put 1 and 3 this way, can you see that my outside is 6 and my inside is 1? With an outside of 6 and an inside of 1, that never makes minus 1. But if I'd put the 3 here and the 1 here, can you see that my outside is 2 and my inside is 3? Do 3 and 2 ever subtract to get you negative 1? Yes. What's going to have to be negative, the 3 or the 2? The 3 to get a negative 1. So we'll make our 3 negative, and our 1 positive. So our outside is positive 2, our inside is negative 3. That will get us our negative 1. Whenever you factor, the last thing you do, and this is why we needed that frantic foiling time, is you quickly foil this in your head to see if you're right. Does it work out? Do the first ones, give me the first one. Do the last ones, give me the last one with the right sign. And do my outside and inside combine to give me the number in the middle. Next one, a 3x squared. Only possibility is 3x and x. What do we have for 15? 1 and 15, 5 and 3, but now we have to consider our outside and inside. Sometimes you're going to do this in pencil and you're just going to try, because you're like, I don't know. What would you like to try first? 5 and 3. So you just write it in pencil, right? Outside is 9, inside is 5. Does that ever make 14? Yes. So I think this is going to work, so I'll write it in darker. Now I need a positive 15 and a negative 14. If I make them both negative, I'll still get a positive 15 for my last one. My outside will be negative 9. My inside will be negative 5. And that'll make negative 14. These ones with a number out in front are a little bit harder because the outside gets affected by that number in front, so you got more options. When it's just an x on the outside, these ones are easier because those are just one x's. So your outside and inside, you can actually mix them up a little bit, and it doesn't matter. 24 to get 11. 8 and 3, excellent. Plus and plus because it needs to be a positive 24 and a positive 11. 2 and negative 8. It's going to be 4 and 2, right? And we're going to need our 4 to be positive and our 2 to be negative. So we get a positive 2 in the middle and still get our negative 8. Awesome. So here are some for you to try back in your notes. So try these on your own. I'll give you about 30 seconds for each one, and then I'll put up the answers. Oh, we got to make it a little smaller yet, so you can see all 5 of them. First ones have to be x and x. To get 12, you could go 2 and 5 or 5 and 2 here. It wouldn't make a difference. Doesn't matter the order that you write your factors. Oh, 12. That is bad math, eh? Wow. 3 and 4. Yeah, 5 times 2 is 12. Nice. Now for the second one, when you went to do it, and you had x and x, the only way to multiply to get 13 is 13 and 1, right? 13 and 1. Now, our 13 has to be positive. But if I do them both positive, my outside and inside makes 14. If I do them both negative, my outside and inside would be negative 14. Those are all the possibilities that could be possible, right? There's no other ways we can multiply to 13. This one is not possible. There will be some that you can't factor. So did you get stuck on that one for a while? Yeah. So that one, you try all the possibilities and it doesn't work, then it's not possible, it's not factorable. Here we're going to get x and x to get 18, 8 and 2, and minus 8 and plus 2. Now when I check this one by foiling it, everything works out, so I know that it works. So that's why you always need to, once you're done, quickly foil it in your head, check if the last ones work, check if the first ones work, then check if the outside and inside match. To get 20 with a minus 8, okay, 5 and 4 gives me 9. 10 and 2 gives me 8. And we'll go minus 10 plus 2. I'll check my last ones work, my first ones work, my outside and inside works. And this is where your times table comes super important, because you have to see 56 and know all the ways you can multiply quickly to get 56. Most common is 8 times 7, and 8 and 7 does make 1. Now I will need my 8 to be negative and my 7 to be positive to make that work. Five more. Just make them small so you can see them all. It's going to equal x, 9 and 4, both negative. Do a quick FOIL to see if you're right. The last ones make positive 36, and the outside and inside make negative 13. Perfect. First ones have to be x and x to get negative 24. Now this is why this one's a tricky one, because x and 4, that makes 10. And if you put that down at first, 6 and 4, and then you say, I need negative 24, so one has to be positive and one has to be negative. But as soon as I do this one positive and this one negative, when I check my outside and inside, I don't get 10 anymore. So I'm like, oh, maybe I had to make this one negative and this one positive, and I check outside and inside, and it doesn't work. So you might be tempted to say not possible. However, what also multiplies to give you 24, other than 6 and 4? 2 and 12. And does 2 and 12 ever make 10? Yes. If I go 2 and 12 and I make my 12 negative and my 2 positive, then I'll still get negative 24. And outside and inside make negative 10. So one of the things, as you do more and more of these, like I often just check adding and subtracting right away because I'm not worried about, just check my numbers like 9 and 4. Do those add or subtract to get 13? Yes, and then I try them. But there is a hint built in. If the last number is positive, the two numbers add to get 13, 9 and 4. If the last number is negative, the two numbers subtract to get 10. That's why 12 and 2 works and why 6 and 4 doesn't. So in the next one, now that I have adding, now I'm thinking 6 and 4 will work, because 6 and 4 adds to 24. And I'll have to make both of them negative. Still gives me positive 24, but that way I can add them together to get negative 10. Now we get numbers in front. So this adds a little bit level of complexity. Not too bad to get 2x squared. The first ones are still easy to find, 2x and x. But now I can't just think of 5 and 1 adding to get 11, because that 2 in the front is going to affect things. In fact, now, unlike the ones we did previously, putting the 5 here and the 1 here is different than putting the 1 here and the 5 there. Because we do have an outside and an inside, and that 2 that's in front affects the outside. Can you see now that my outside is 10 and my inside is 1? Does that add to make 11? Yes, it does. These would both have to be positive to get the positive 5 and the positive 11. Can you see why the 5 first and the 1 last would not work? Because if the 1 was last, my outside would be 2, and my inside would be 5. Finally, has to be 3x and x. How can you get 8? 2 and 4? 4 and 2? Good. Those are two different possibilities. Also 1 and 8 or 8 and 1. Now what's going to work with outside and inside? Where do we need to put things? Four on the outside?
No, 4 on the inside.
4 on the inside? I like the 4 on the outside. What happens if I put the 4 on the outside? What do I get on my outside? 12. I wanted that to be red. There we go. 12. And what do I get on the inside? Does 12 and 2 ever make 10? Yes. And I want it positive 10, so I'm going to make my 4 positive, so I get a positive 12. My 2 negative. Yes.
Couldn't you also put the 4 in the center too,
Let's try it. Let's try putting 3x and x, put the 4 in the center and the 2 here. And still, which one do we want to make positive? The 4 positive and the 2 negative. Oops, I need my x here. This will still give me 3x squared for my first ones. It'll still give me minus 8 for my last ones. Can you see that my outside now is going to be minus 6x and my inside plus 4x, and when I simplify that one, it comes out different. So it does make a difference if you switch the 4 and the 2 when you have a number in front. This is the idea of factoring. You can also factor with algetiles. We'll look at that in a bit. I'm going to show you your homework assignment just so you can write it down. So here's your homework assignment, just so you can write it down. And then we're going to learn factoring with algetiles as well. Everybody ready? All right. We'll do some more factoring tomorrow as well. Okay, algetiles, factoring. Got to get some white paper here. Put on our camera, slide it down a little bit. We need an x squared. There's an x squared tile. Negative 5x's, so now my positive tiles are blue. My negative tiles are going to be red. And I need to have a volunteer come up here and make this into a rectangle. 3, 4, 5, and 6 ones. Who wants to come up and make a rectangle and gain instant YouTube fame? Don't all jump up at once. You just have to rearrange these to make a rectangle. Is this a rectangle? No. It's close to a rectangle. All right, there we go. Not a very good rectangle. this gonna work? No. Oh, yeah, I think we just got a volunteer. Come on, we need someone to come up and make a rectangle. You can't. This also is cheating. If no one volunteers, I'll pick someone to volunteer somebody else. All right. Davin, you get to pick someone. And you can turn the red ones if you like. Oh, it doesn't quite match up there though. See here? If we line this up, it's not perfect.
Oh, okay.
It's got to be perfect. Those don't quite perfectly match up. You can turn them. Yeah, that works. But they match up. Right, but you can take these things, turn this way too if you like.
Oh, yeah.
Of course I know how to make it. Still have 2 left, so you're not done. All right. Let's line it up nicely. Oh, doesn't that look pretty? Let's rotate it so those people that are OCD and don't like things crooked. Autofocus. Nicely done. Take a picture of that. Good job. So how does that help us factor? Well, the area of the rectangle that he just built is x squared minus 5x plus 6. Can you see that? How long is this? How long is this?
That's 2x squared. And then
Well, remember the area of this one's an x squared, so its lengths are x and x.
2x. And then that length is...
And these ones' lengths are all ones.
No, that's 2x.
All right, this is going to be x, okay? And this part's going to be x. What are we going to do with the red ones? 2, but it's got to be red. There's got to be a negative 2 there. And to get these red ones here, we're going to negative 3 here. And I hope you like the algebraic method of the FOIL better than drawing these rectangles. But the rectangles are fun, but you're going to get x minus 2 and x minus 3. Does that FOIL to give us our first ones, our last ones, our outside and inside? Yes. So if you would like to, you can always attempt to build the rectangle. But you might find the unfoiling technique faster. That's why I didn't show you this first. Should we get another volunteer? I think so. Pull up the screen. You know what's the nice thing about volunteering first? You get to pick the next volunteer. These ones are, we get all blue tiles this time. I need 11, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I'm out of blue ones. I've got to open up another package. You're like another package. There you go. There's only going to be one rectangle that works. Oh, those won't match up ever. These ones, if you try this, like if you look at the,
Oh yeah, okay.
see it's a little bit too long. They will match up with the X side, but they won't match up there.
Okay.
It's a variable.
Oh, do you need one more big blue one, eh? Did I not give you 2x squareds? There you go.
There's so many skinny ones.
Factor it while you're waiting for him to build it. Factor it by hand. And then once someone's factored it by hand, use your information that you factored by hand to help build him the rectangle. The ones won't match up, they'll be a little bit short.
No.
Someone factored it by hand already? You want to come up and help them? Or do you what did you get as a factor? 2x plus 1?
Yeah.
And then on the other side, x plus 5?
Yeah.
So if I make this side 2x plus 1, and the other side x plus 5, there'll be 5. You see it's going to work?
Okay.
That was a hard one. So again, you can see that if we start to try to build these rectangles by hand every single time, you'll see why the algebraic method of 2x and x and 5 and 1, well, that's what this is. This side is x, x, and 1, and this side is x, 1, 1, 1, 1, 1. And you get 2x plus 1 and x plus 5. So no one's going to go home and buy a bunch of algae tiles to do their homework?